Hello everyone and welcome to our fourth video on our discussion on angular projection. We are still discussing projectile motion. In this module, we will talk about maximum height. We spoke of time of flight in our previous module and we will pick up from there when deriving the formula for maximum height. So let's take a look at what exactly do you mean by maximum height. Now by definition, maximum height is the maximum vertical height attained by the object above the point of projection during its flight. It is denoted by capital H. So you can see maximum height is this red arrow that goes from A to H, and that's the maximum height. Basically, it is the height that the object attains or the distance between the point of projection and the maximum height, the vertical distance between the point of projection and the point of maximum height. So this is the maximum height and we want to find a formula for maximum height. Now as you can see, I have already written the formula for time of flight down on the board, which means I'm going to need and use the formula for time of flight for this module. So if you're wondering where did this formula come from, go back to the previous video and see where we derived the formula for time of flight. We are going to directly use that formula in this module. Now what I'm going to do is, since maximum height is nothing but the vertical distance, I'm going to obviously use a kinematical equation but for the y direction. Now when I want to do that, let me recap what this diagram stands for. U is the initial velocity, u cos theta is the initial horizontal velocity, u sin theta is the initial vertical velocity. At the point of maximum height, you can see u cos theta is the horizontal velocity. You can see it hasn't changed and there is no vertical velocity because the vertical velocity is 0 at maximum height point. Now using this information, I am going to find the formula for maximum height. Now first of all, I say that taking the vertical upward motion of the object from 0 to h, what I have is as follows. I say that the initial velocity of the object along the y direction is u sin theta. We already know this by now. I say that the acceleration along the y direction is minus g. Let me recap. The only force acting on the object along the y direction is the gravitational force, and therefore the acceleration will be acceleration due to gravity, that is g. And why do we have a negative sign? Because as the object goes up, its velocity decreases, and because of the decreasing velocity, acceleration is negative. So ay will be minus g. Y naught is 0. Y naught means initial displacement. Object has begun from the origin. We are considering the point of projection to be the origin, and therefore I see that the initial displacement of the object is 0 because it begins from origin. The final displacement of the object is nothing but capital H, which is what we have called this distance, and therefore the final displacement is capital H. So from no height at point 0 to a height of h, therefore y naught is 0 and y is capital H. Finally, I will also say that the time it takes to go from this position to this position is nothing but capital T by 2. If you recall, capital T is the total time of flight, and the time it takes to go from 0 to this point h is half the total time of flight. This is something we discussed in the previous module also. I am simply saying that the time it takes to go from here to here is half of the time it takes to go from here to here. And therefore, I have written small t is equal to capital T by 2. Finally, I want to say that this small t is equal to capital T by 2, but I know what is capital T, that is 2u sin theta by g, and therefore I will bring this down and I will say that capital T by 2 means 2u sin theta upon g divided by 2, and this will give me small t is equal to u sin theta by g. Now I will use these values and I will put them in the kinematical equation y is equal to y naught plus uyt plus half ayt square. In this kinematical equation, we'll put all the values that we have discussed. We know y is capital H, so I'm going to bring that down here. Y naught is 0, so that will be a 0, plus uy is here, u sin theta. Then you have t, and t is nothing but u sin theta by g, so bring that down here, plus half ay is nothing but minus g, that's here, into t squared, t again comes from here, and then I'm going to reorder and rearrange this equation. Once you solve that equation, what you get is h is equal to u square upon g sin square theta minus half u square sin square theta by g, and this gives me the final value for h, that is h is equal to u square sin square theta by 2g, and this is the formula for the maximum height. where theta is the angle that the initial velocity makes with the x-axis. You can also read this as the square of the initial velocity along the y direction, because I can write this as u sine theta the whole square upon 2g. So you can also read this as uy square upon 2g, right? And therefore, maximum height is nothing but u square sine square theta upon 2g. Be careful between the formulae for maximum height, time of flight and horizontal range, because they are all in terms of theta and the initial velocity and g. Usually students get confused between these formulae, so be careful. Here we derived the formula for maximum height. So thank you for watching this video on maximum height. We derived the formula for you. If you like our channel and want us to make more videos, please subscribe to the channel. The link is below. And if you want to buy your very own target book, we have also provided a link to that. So keep watching and stay tuned.